So I've taught statistics for many, many years. And before I started using Excel to teach statistics in, I guess, 1992, we would use the stat books and they would always have these things called Z tables to compute normal probabilities. And it was absolutely horrible to teach from the Z tables because every book had a different Z table. Well, Excel really makes these Z tables obsolete, and basically we can, using the norm dis function and norm inverse functions in Excel, solve many interesting probability problems involving the normal random variable. So what is the syntax of these two functions and what do they do? So if you do norm.dist and you put in a value of x, okay, and a mean and a standard deviation and put in the word true, you do need that word true. It gives you the probably a normal random variable with the given mean and sigma is basically less than or equal to x. And it's also less than x. So like, because we said before, what's the chance somebody's exactly 6 feet tall? It's 0. So whether we say less than or equal to or less than, when we talk about our normal random variable, we really get the same answer because it's a continuous random variable. Now, you could change true to false here, but we'll not do that in this course. But if you change true to false, you get the height of the normal density if you're interested in that. But make sure you put the word true in there. You get the probability of normal random variable is less than or equal to x. So as an example, what's the fraction of people with IQs less than or equal to 90? We'll do some more complex examples in the next example. So we do norm dist. We would put in 90. The mean is 100. The standard deviation is 15, and we need that word true to let our true probabilities come shining through. Okay, we get 25% of people have IQs less than or equal to 90. Now here's a picture to show you that, again, courtesy of Palisades at-risk package. See, if I look at the normal density for IQs here, mean 100, standard deviation 15, the area under this whole thing is 1. What fraction of the area is less than or equal to 90? It's this shaded area, and it's 25%. Okay, now we can also get percentiles of a normal random variable. Norm.inverse p mu sigma gives the pth percentile, like if p is 0.9, the 90th percentile of a normal random variable with a given mean and sigma. You don't need that true or false. If you put p as 0.1, you get the 10th percentile. You put p equals 0.5, you get the median. Okay, p equals 0.6, you get the 60th percentile. So if I want the 90th percentile of IQs, of course that should be higher than 100, use your common sense, that should be a fairly smart person on the IQ test. So I would do norm.inverse, okay, probability would be 0.9, the mean is 100, and the standard deviation is 15, and I get 119.2. So if we look at this picture, it should be 90% of the area is to the left of 119.2, and that's exactly true, and 10% is to the right of 119.2. So in the next video, we'll continue with the applications of these functions to compute normal probabilities.